Hi everyone, my name is Sahdev Zala. I work at IBM as senior software engineer in United States. I am one of the lead for the special interest group IBM Cloud, and I also contribute to upstream Kubernetes.
大家好，我叫刘光亚。那我现在呢，主要负责的是 IBM Cloud Project 研发工作。那因为我们的 IBM Cloud Project 主要是基于开源项目去做的，所以我也参与了很多这种开源社区的一些开发工作，包括 Kubernetes Istio Foundation 等等。OK。
All right, so this talk, we're going to have a little deep dive into the SIG activities and other things we do around this SIG. We had an introduction session yesterday, and we covered a lot of things, more like an overview kind of thing. So we're not going into a whole lot of overviews today. We'll just quickly go over through a few things, and then a little discussion around what any improvements or suggestions you have for the SIG. So the agenda is a very quick overview about structured activities, a little bit about IBM Cloud, public and private, and we'll talk about IBM Cloud provider code, and then the upstream contributions from the SIG members and IBM Cloud team. We're also going to show a demo of multi-cloud manager as part of this talk, and then we just summarize the talk. So the SIG is for building, deploying, and leveraging Kubernetes on IBM public and private clouds. IBM is a big believer in hybrid cloud, and we have IKS or IBM Cloud Kubernetes Service on the public side, and then we have IBM Cloud Private, which is more like an on-prem offering, or it can run it on its own on the public side as well. We believe the workloads are going to be on the public side and the private side between them. And both platforms, IKS and ICP, are certified with the Kubernetes Performance Test Suites. As part of this SIG, you got to know the people behind the IBM Cloud, both the platforms. So you interact with them directly, and we would love to have more folks joining the group. Also want to mention that the SIG was created early this year, so it's I think one of the latest SIG in the Kubernetes. And this is our first time talking at a KubeCon, just giving updates. Structure: the SIG meets every other week, and the recordings are out there on YouTube. If you have missed the previous meetings, I would highly recommend to look at the videos. We have 3 leads: Richard Thies from IBM Cloud Kubernetes Service, Khalid Ahmed from IBM Cloud Private, and myself from the open source side. There are a bunch of links out here. You can read more about the SIG, the SIG charter, and there's a mailing list link as well. So please join the SIG. The SIG meetings, again, not going into a whole lot of detail here, but we basically have 2 parts. That's typical meetings. One is, it's similar to the Kubernetes community meetings. We have someone from IKS or ICP side giving a little overview of some of the latest thing happening over there, and with regards to Kubernetes, for example, like update strategy for the IKS, or scalability testing with the ICP and whatnot. And then second half, we pretty much talk about the community work we've been doing, and that includes a whole lot of different topics, and typically every meeting ends with open discussions. We usually have around 7 to 10 people joining the meetings. Just providing a very high-level overview about IBM Cloud Kubernetes Service. As I mentioned, it's a public service managed by IBM. Provides an intuitive user experience with simplified cluster lifecycle management. It comes with built-in security and isolations, and one of the biggest benefits you get is it's easy leveraging of around a couple hundreds of cloud services from, whether it's from weather data, IoT, or analytics, or AI sides. It's available in 6 IBM regions worldwide, which includes over 25 data centers. And as I mentioned earlier, all the 3 supported versions, 1.9, 1.10, and 1.11, are Kubernetes certified. Talking about regions and data center, like 6 regions are around the world in North America, Australia, Europe, and Asia. And as I mentioned, there are 25 plus data centers. The IKS comes with all these Kubernetes capabilities we love, including intelligent scheduling for best utilizing the resources, self-healing capabilities, scaling with horizontal path scaling or through the commands, service discovery, and out-of-box load balancing, automated rollouts and rollbacks, and then secret and configuration management. On top of that, in talking about Kubernetes management capabilities, the IKS comes with the simplified cluster management experience. You have options to manage your cluster through graphical user interface or command line interface or via APIs. You as a user design your own cluster, whether you want compute to be shared with others, your isolated compute, whether you want multi-zone cluster or single zone, you design your own cluster. Container security and isolations with things like vulnerability advisor. And as I previously mentioned, you can extend it with couple hundred sort of services from IBM Cloud and Watson, and it comes with 100% native open source experience. And the one last thing is integrated optional operational tools, right? Your monitoring, logging, and security, as I mentioned. And we have one architecture for the public side, for the private side. So more look and feel, the user experience remains same for most of these things I've been talking about. Here I just want to mention that we use IKS internally. We have IBM Watson. I guess everyone knows about it. And this is just about Watson AI workloads. One huge deployment. Just an example here: 3,000 plus pods running on 500 plus nodes, and you can see a quote from Watson team how happy they are using the having IKS manage their infrastructure versus they used to do by themselves. All right, so just quick recap of all the benefits I've been talking on IKS side. What you get is multiple data centers where you can deploy your clusters. You got a support for ingress and load balancer networking options. The extension part earlier I talked with the dynamic persistence volume support. Highly available and managed by IBM Kubernetes masters, and you can enhance your apps with around a couple hundred services from IBM Cloud Catalog, including Watson, weather, and IoT stuff. And the one last thing I want to mention here before I hand it over to Guang is IBM Cloud Provider Code. We had a discussion in the SIG meetings. We had a talk with the cloud provider SIG, under which we are working on moving as a sub-project for the provider code. So IBM Cloud Provider Code has been created long back when there is really not a cloud provider SIGs out there. So they are still internal in the IBM internal repos, but we're working on making them external. And our goal is to have one repo, and that will be the external repo. We're shooting for Kubernetes 1.13 release. So we're working on all this internal legal stuff, and then also as part of making this open, we'll be having some refactoring there. And like I said, our goal is to have one repo at the end. one of the SIG leads, Richard, he regularly attends the SIG Cloud provider meetings, and we follow them closely for the requirements around this code repos. So that will be coming soon around 1.13 release. So that's pretty much it. I'll hand it over to Guang, and then I would like to have any questions or at the end, or in between as well. But we're going to have some discussions or any suggestions from you. We should keep in mind. So yeah, Guang.
Okay,
thank you. Thank you.
And now I'm here to share with you. In the SIG of IBM Cloud, we have two important product, IBM Cloud Pride and Cloud Manager. We talk about the Cloud Provide. It is a brand new product we just launched around the world. It is based on Kubernetes Enterprise platform. We have different VMware product, Altair, and other product, and we can support support x86, etc. And today we're going to share with you our test. We have the private scalability test, and in two of these releases, we have done this Kubernetes 1.9. We checked about 500 nodes. From this, you can see where we did our test. It's Kubernetes and Calibre use the same ETT. All of this data are shared through same ETAD, and also you can see Calico tests. When you see this network, we use Node Nash to manage that. And also you can see we have a Kube lower version 2.6, and use ETAT API v2, so that the performance may not be very good. And when to move to Kubernetes 1.11, we did a bigger test, and for the deployed architecture, we made our management. From this slide, you can see the first change we did is we checked the ETAD apart. The Kubernetes and the Calibre, these two ETAD are no longer shared. In that case, when there's a Calico have higher load, this will not influence the API server. This was the first change we did. That is, we put ETAD two parts, and also we upgraded the Calico, as you can see, from version 2.6 to 0.0.4. After we reach that version, the best advantage is we can use the ETAD v3 API. We have done our test, and the result is ETAD v3 performance outperform ETAD v2 by more than 2 times. And also we can see, other than the two changes, we also have the Calico network no longer managed through no mesh. We have Respector to manage that. And in that case, we can no longer build up a peer connection among all the nodes. The best advantage is that it reduces the nodes connection. Therefore, we have made all of the changes in Kubernetes 1.11, and you can see expand our scale from 500 to 2,500. And you can see for IBM, we just have the product last month called Multi-Cloud Manager. Why would we need multi-cloud? We talk about the reasons. Different users have different needs. Some of the users may have some legacy apps, and for that, they need to migrate to other cloud. If you have a new servers here, they have to use a new platform to manage that. In that case, we need to guarantee that legacy services would be able to coexist on this new cloud. We have a multi-cloud platform to manage that. And the last reason is that sometimes the user do not want to be locked to certain vendor. They don't want to be put all eggs in the same basket. So we want to help our user to diversify so they can have a solution to manage multi-cloud. They have more options, and they can manage their workload upon different workload. So this is our IBM Multi-Cloud Manager framework, and we already talked about it yesterday in terms of the major functionality. And now I will have a deep dive demo. I'm going to demo to you all of these main functions we have in here.
So as for IBM Cloud Private, some of you might wonder its relationship with OpenShift. So actually we have a long-term partnership. So as for IBM Cloud Private, there are some core services like mounting And this can be apps on the OpenShift. So for IBM Cloud Private, it can actually run on OpenShift. So with ICP UR and login and mounting, this can manage the Red Hat OpenShift preemptive apps. Next, let's take a look at the contribution of IBM to open source. So multi-cloud manager and IBM Cloud Private are all based on open sources. So we need to devote a lot of capabilities in it so that we'll get to know about the trend in open source. And then we can provide the solutions for our users. So currently, here are the major projects. So one is Kubernetes, and now it's ranked number 6. So we have done a lot of research manager. So second, we have also done a lot of storage-related solutions. And then it's based on Kubernetes. So for our users, they are faced with some challenges, and then we can provide feedbacks to that. And then we can also fix the problems and provide patches for the users. Second is service mesh. So as you can see here, last year, this was launched by 3 companies, and IBM is one of the leads, and we ranked number 2 in terms of contribution. So as for the service net, then we provide a component for controller. It's called A8. So it is used for workflow control. The third one is Kubernetes Federation. Starting from March, this project has been launched, and this is to replace V1 of Kubernetes Federation. And then it's initiated by Red Hat, Huawei, and IBM. There are weekly meetings in which we discuss the trend of the project, and also we would talk about any questions in the roadmap. So these are the major projects in open source. Apart from that, we have other projects like a cluster registry, application, and ingress controller. And we have made a contribution in all of these areas. In terms of cluster registry, so this is one of the major components for keeping track of and perform operations on the clusters. As for application, so the major reason for application is that for Helm, this is going to get rid of V8, so it's going to be used by IBM Multi-Cloud Manager. So we hope to have a young template to define the different components. The last one is the ingress controller. So the major function is access Kubernetes service via ingress. So for the user, they can actually define the name, and then we decode the name, and then we can transfer it to Kubernetes, and then use the ingress controller to visit it. So we have done tests on it. For example, when ingress controller is used by IBM Cloud Private and IBM Multi-Cloud Manager, there are some tests that should be conducted. Next, I want to give you a demo, which is about IBM Multi-Cloud Manager, and take a look at its functions. So here, I would like to show you a video. So this video is the demo which I have recorded. So here, this is cloud control. So this is first cluster with one node, and then there is another node, and then this is R44. And then this is IBM Cloud Private. Then we log in to see how many resources there are. So this is the UI, and with that, we can actually log into the IBM Multi-Cloud Manager. So this can actually give you an overview. With that, you know how many clusters, how many pods, how many services there are. And this will also show you in different clusters how is the use of resources. Here are 2 clusters with different Helm list and with the pod and the storage information. And then in this system, this is the cluster information, which is below 75%, and memory is between 75 to 90%. And here it shows that the storage status is between 75 and 90%. Apart from that, you can also click on Ready to see the cluster information. Also, you can click View All. As you can see, there are 2 clusters. And then there are different labels for the 2 clusters. So when you do deployment, then you can actually choose the specific deployment based on the labels. So on each cluster, there are specific labels like the region and the vendor information. And then you can also choose the specific labels. For example, you can choose the channel or region. And also you can click on Launch. So this will navigate you to the IBM Cloud Private. So this is the IBM Cloud Private UI. This can actually show you each cluster and the nodes and the storage information. This is another cluster. And also, when you click on the cluster, you can view all the information of the clusters. So in the overview, you have already checked the information. And here it can also show you the node information. So in cluster 1, if you click it, you can find all the information about the nodes. And also, this is a policy. So as for policies, you can actually monitor the clusters. If there is any variation in the cluster, it can modify it. For example, this is the policy. So this will monitor the cluster, and it will see whether the row is deleted. If yes, then the policy will create this row. So this is the policy. And with group control compliance, then this can define the policy. And with YAML, this can further demonstrate the policy. So here is the details of the policy. So as you can see, this is the policy. So this is about the role name of each cluster. And the compliance tab is must-have. So that means this row is necessary, and if this row is deleted, then it will be created automatically. And then this row will be deleted. And then the policy will actually create this row. So this is the detailed information about it. So this is the row information. So as you can see, this is the operator which was created 10 days ago. And then this row is deleted. And then you can see that it is automatically created. So this is how the policy works. If there is any violation, then it will create it automatically. Apart from that, then we can also manage the applications. Here is the UI. So as for the application, then we can actually do our deployment like this. So this is the detailed information of the guestbook. So this is the design. So it shows the different components. As you can see, there are 3 components like guestbook, register master, register slave. So these are the major components. And then with the 3 templates, the YAML documents can also be defined. So with that, this can show you more detailed information. And then this is topology. This can help you to check on the relationship in the system. As you can see in this application, there are running slave and register master. And then there are also deployment service, which has also got certain kind of relationship, and it can be shown in this system. Next, we can also make other options. So this is Helm releases. So this is deployed through Helm Trust. So all the deployments are released like this. And there are different clusters. And then we can also check the guestbook. So the guestbook is on cluster 221. So this is the present policy, so which shows that it will define which cluster it will go to. So here is the information about the pods, and it shows the specific cluster and the labels of each pod. It will also show you the nodes of all the clusters. So on the multi-cloud, this shows you all the information on the system. So here there are 2 clusters, and it also shows the nodes of the clusters. And also it shows you information about storage. So it can show you all the cluster storage and the PV and PLC information. It can also show you the topology. So when you click on topology, this can show you all the services here. So here, all the clusters, all the services are demonstrated here. So all these can actually show the relationship between the different services. Next, let me show you the placement policy. So this is PP, which is short for placement policy. So as for the guestbook service, then here this is deployed on cluster 21. Then the number can be changed to 2, and then everything will be doubled, and then the decision will also change. And then you can also get policy, and then YAML. So now the application is running on 2 clusters. So it's running on cluster 21 and 11. So now the number has been changed from 1 to 2. And then we can check it on UI. So this is the Helm release.
And from here you can see we used to only have it on 2.1, but it's no longer on that. So it is on both of that, and it is on 2 of the clusters. And then we can continue to be here to, it is a policy, and I can change that to 1, and you can delete it over here, and you can keep on with the policy, and you can see it changed to 2.1, and that is to I deleted that, and you can check it on UI, and you see the guest book, and you can see it changed from 2 to 1. We have deleted this one. So other than being able to see different applications, we can also view the health state of the app. We can put it in the dashboard to see where the app is on which the cluster. You can see it is on cluster 2.1. We can also see the memory, the CPU utilization rate, file system, etc. So that is the multi-cloud manager demo I want to show you. 好的，让我的同事来给大家做一个总结。
So we can keep it separate. So yeah, thanks everyone. So I want to summarize it as, our goal at SIG IBM Cloud is to provide a platform for open discussions around IBM Cloud Kubernetes service and IBM Cloud Private with respect to how we leverage Kubernetes, how we support Kubernetes, and based on those discussions, how we contribute back to the upstream Kubernetes. Okay. And our near-term goal right now is to open source the cloud provider code, and we would like folks to join the SIG discussions, and reach out to us anytime on the SIG Slack channel or via mailing list or through our Twitter IDs. I would love to help out in any way we can. So thanks everyone again, and we can take any questions if there are any, or just let us know afterwards. Thank you.